Hi, we're back for the second video here, solving 9.6b, solving exponential and logarithmic equations. So now we're moving on to a log equation where we might have to use some of the properties, and we may not. It just depends on what we get when we're doing this. So let's go ahead and start. I'm going to zoom in here onto this equation here. So I only have one log, and I know that it says 9 times log base 5 of negative 5x. It looks like minus 5x. I do want to say that this is not, this should probably be in parentheses because that's a negative 5x. So it's not subtract 5x. I just want to point that out. So before I do anything with the log, I need to get the log by itself. It has to be just kind of like the exponent. I want the log, if I only have one log, I want the log and whatever the whole log part to be by itself. So the log, the base, and whatever it is too. So log base 5 of negative 5x. I need that to be by itself. So how am I going to do, what am I going to do to get that by itself? Well, it says 9 times that, so I'm going to divide by 9. And I'm going to divide by 9 on both sides. So then I get log base 5 of negative 5x equals 4. Is that good? 36 divided by 9, yep. So if I cannot solve it as a log, right, I change it to a exponential. Great. So it becomes this, my base to this equals this, right? So that's how we write it. So I've got 5 to the 4th power equals negative 5x. So now I'm just going to work out the math. Well, 5 to the 4th power, 5 times 5 is 25. So 25 times 25 is 625 equals negative 5x. Great. And then I'm going to divide by negative 5. So x is going to equal negative 125. Okay, great. That one wasn't too bad. So let's go ahead and try the next one and see what it says. Okay. So I'm going to go ahead and highlight my log and what I need to get by itself. So here's my log. This is what I need to have all by itself. Okay. Okay, so it says negative 1 plus. So what's the opposite of subtract 1? Well, that would be, this time I'm going to add 1 to both sides because I'm not multiplying, I'm adding. Okay. I'm adding that negative 1, so the opposite of negative 1 is plus 1. So here we go. I've got log base 12 of x plus 10 equals 3. Okay. And then I'm going to take my base, so that becomes 12 to the 3rd power equals this. Woo! Okay, 12 to the 3rd power. So I'm going to say 12 to the 3rd power equals x plus 10. To get the x by itself, I'm going to subtract 10. So in my calculator, I'm just going to tell you, I'm just going to put that into my calculator. I'm going to do 12 to the 3rd power minus 10, and I get 1718. So that means 12 to the 3rd power should be 1728. Okay, so that's how I just put this into my calculator right here, into my calculator, 12 to the 3rd power minus 10. Okay, good job, you guys. Next problem here, let's see what we've got. Looks to be like a similar type problem to what we've been doing. So here we go. I'm going to go ahead and highlight my log, which is here. Okay, what do I need to do to get my log by itself? Well, that's 6 times a log. They're touching, so I'm going to divide by 6. Beautiful. Then I'm going to say log of 12 times x minus 2 equals 3. Okay, so I've got 12 to the third power equals that, x minus 2. I don't know why I'm saying that. So I've got 12 to the third power equals x minus 2. And then I'm going to add 2 to both of them. And I'm going to put that in my calculator. And I'm going to get x is going to equal 1730. There we go. Okay. Not too terribly bad. All right. Here we go. Oh, I've got 3 logs. Okay, well, let's think about this for a second here. Well, let's look at this side first. Let's look at this side first. What does this minus sign mean? That minus sign means I can write those 2 logs as a division. Okay, so I can say log base 6 of 4 divided by 3x plus 3. And that's going to equal log base 6 of 70. Okay, that's not too terribly bad. And then the rule says if I have a log on 2 logs, one on either side of the equal sign, and they have the same base, right? So I have 2 logs, one on either side, and that's all I have. There's nothing else. Then this equals this. Okay, so that's what I'm going to do. So I'm going to rewrite this as 4 over 3x plus 3 equals 70 over 1. So now I have a fraction equaling a fraction. How do I solve that? Well, I cross multiply, so I'm going to take that times that and this times that. So I get 70 times 3x plus 3 equals 4 times 1. Give myself a little bit of room and slide up here. So distribute. So 70 times 30x is 210x plus 210 equals 4. Okay, so we're pretty good so far. So let's subtract 210. So we get 210x equals negative 206. And then I'm going to divide by 210. So x is going to equal negative 103 divided by 105. Okay, nice job. So there's my answer. Wasn't too bad, a little bit longer work, but not too bad at all. So here we go. We're going to go on to the next problem. Let's see. We're going to go to the next page here. Here we go. Similar type problem. I've got 2 logs on one side with a minus sign in between them. So what does that minus sign mean? It means I can rewrite the problem as a division problem. So I've got log base 3 of x minus 1 over x minus 5, and that equals 2. And now I have 1 log that I can't, so I'm going to rewrite that. If I can't solve it as a logarithm, I'm going to solve it as an exponential. So, and I erased it. Good job. Okay, so log base 3. So sorry, guys. So I'm going to take this to the second power equals that. Okay, so I've got 3 to the second power equals x minus 1 over x minus 5, and that's over 1. So how do I solve that? Well, you're going to cross multiply. So I get 3 squared is 9. Good. So that's 9 times x minus 5 equals 1 times x minus 1. Woo. Okay, let me give myself just as many lines as I can here. So 9x minus 45 equals x minus 1. Now I need to solve for x. Okay, so I'm going to subtract x, and I'm going to add 45. Okay, so 9x minus 1x is 8x equals 44. And then I'm going to divide by 8. So x is going to equal 11 halves. And there's my answer. Beautiful. Not too bad. Not too bad, so bad. Not too bad so far, if I can talk. And our last problem for today. Here we go. Okay, same thing. Pretty much the same thing. We're going to do the same thing. I do want to point out if this is if this is a add instead of a subtract, what does it become? Times, right? So just be aware of that. Sometimes on your homework it might be a plus instead of a minus, and I would times the 2 instead of actually, you know what? Let's go ahead and do that. I think we can change this to an add problem. So we're going to go ahead and change this to an addition problem so you can see what we would do. Yeah, let's do that. So this is plus. So I'm going to rewrite this as log base 3 of 2x plus 8 times 8 equals 2. So if I can't solve it as a exponential, I'm going to switch it to if I can't solve it as log, I'm going to switch it to an exponential. Woo! My brain's working really well this morning, you guys. So here we go. I've got 3 to the second power equals 2x plus 8 times 8. So let's work out the math. So 3 squared is 9 equals 16x plus 64. Subtract 64. And that would give me negative, negative 55 equals 16x. Divide by 16. So x is going to equal negative 55 divided by 16. And there we go. Good job. Okay, so we're going to be done with this. You're going to go work on some problems, and I will see you back in a little while for the last section. Talk to you soon. Bye.